all right, now we want to actually use Newton's method with which has this algorithm that's given here to actually go ahead and try to do something concrete with it. So what we've got here is a relatively simple looking example. We just want to estimate the square root of 2. And if you think about it, back earlier in the semester we've actually done this. But back then we did it in the context of linearization and linear approximation. So I'm just going to add a little extra blurb to this example to make it distinct from the example we've done previously. And I'm just going to say we want to estimate the square root of 2 using Newton's method. Right, so somehow this is, the idea is that linearization really only has one step, right? You find a tangent line and you use that to approximate whatever, somewhat complicated value like the square root of 2 that you're trying to estimate. And with Newton's method, in theory, you could do, sort of infinitely many things, right? You could just keep on estimating these values closer and closer and closer to the actual value. Until your arm falls off. So we're not going to go that crazy. What we're really going to do here, and on an exam I would specify this, we're going to start at a specified x naught. So I'll tell you what the x naught initial guess should be. And then I'll actually also specify where we're going to stop, right? So for this example, we're going to stop with x2. All right, so we're going to start with an initial guess x naught. We're going to use this algorithm to figure out x1, and then we're going to use this algorithm again to figure out x2, all right? And then we'll stop, and we'll say that is our approximation. So one thing to recognize here is that, and this is why I left this header on the board here, Newton's method is a way of approximating roots. Now, you might say to yourself, square root of 2, right? It's a root. But that's not exactly what this means, right? When we say roots here, we mean zeros, of course. And this is just a constant, right? It's just some number. So what we have to do in order to implement Newton's method here is actually something that we've done before this semester. All right, so earlier in the semester, we were talking about this relatively strange question, which I actually had you guys think about on your own, and then we had sort of a large discussion about how we could possibly approach it. And that question that we did before, that this is sort of similar to, was showing that the square root of 2 even exists. And the way we went about it, if you don't remember, maybe pause the video right now, take a couple minutes, try to think about how we answered this question. Right, so we had this question from before where we showed that the square root of 2 exists. All right, so if you don't remember how this went, take a couple minutes, pause the video, take a couple minutes, and try to think about how you might show that this actually happens, right? How do you show that the square root of 2 exists? And if you can't figure it out, look back in your notes. You'll definitely find it in there. It would have been around the material that was eligible for exam 2, if that helps. All right, so pause the video, think about it, and then come back. Now, it's very similar to this idea where we showed that the square root of 2 exists. The way we did this was by first saying that the square root of 2 was the solution to some sort of equation. And then we use the intermediate value theorem to actually say, saying that the square root of 2 exists is the same thing as saying a continuous function takes some value, apply the intermediate value theorem, and you'll get to the right result. So what we need to do is view the square root of 2. In order to apply Newton's method, which is for approximating zeros, we need to view the square root of 2 as the zero of some function. Right? This is really the key step. Right? So we need the square root of 2 to be a 0 of some function. And just like in that intermediate value theorem example that I referenced before, what we're going to do is we're going to consider, right, if x is the square root of 2, well, let's just build up from this and say, okay, this means that x squared is the square root of 2 squared, right? So x squared is equal to 2. And now we're just one step away from viewing this as the root of some kind of function. If we just subtract 2 over, we have this statement here, and now the positive solution of this anyway, because there will be 2 solutions, remember, the positive solution is going to be the square root of 2, which is what we're trying to estimate, and that's going to be the positive root of this function x squared minus 2. So that's the viewpoint we're going to take here. All right, let me summarize. We're going to estimate the square root of 2 by estimating the positive root of f of x is x squared minus 2. And now just to put us all on the exact same page here, we're going to use Newton's method, which I mentioned at the very beginning, but just so we're all on the same page, we're going to do it with x naught equal to 1, and we're going to find x2. All right, so we're not going to do too many steps here because it really gets cumbersome to do by hand. As you might be able to guess just from the notation for the algorithm here, it does become quite cumbersome to do by hand. So we're going to take x naught to be 1, and we're going to go ahead and find x2, the second approximant in Newton's method. So before I do it here, I want you to pause the video and go ahead and try this on your own. You've got the algorithm or you've got the formula in front of you. Just go ahead, pause, try x naught equal to 1. Go ahead and see if you can find by hand the value for x2. Right, so first this is going to involve the initial guess x naught, which is 1, and then you find x1, and then you use x1 to go ahead and find x2. Right, so pause now, take a few minutes, try this, and then come back and I'll run through the solution. Okay? So let's just see if you end up getting the same thing I do. I want x naught is 1, and so x1, just following the formula here, x1 is going to be calculated in terms of x naught, which I'm going to plug into this formula. So that's going to be x naught minus f of x naught over f prime of x naught. So one thing I'm going to keep off to the side here because I'm going to use it repeatedly. F of x is x squared minus 2, and f prime of x, make that a little clearer to read, is 2x. All right, so what we're going to have here is x naught, which is 1. Remember, we have a concrete value for x naught. It's 1, minus f of 1 over f prime of 1. And this is going to be 1 minus, and now be careful with your minus signs and everything here. This f of 1 is going to be 1 squared, which is 1, minus 2, all divided by f prime of 1, which is going to be 2 times 1, which is 2. All right, so what we have here, this is going to be negative 1 over 2. So this is negative 1/2. Double negative, again, be careful with your minus signs. The double negative is going to make it positive, and so we have 1 plus 1/2. In other words, 3/2. All right, so I'm going to keep track of this over here as well. x1 is 3/2. Right, so we're going to be good bookkeepers here. Just keep track of all the relevant information. x1 was 1. Our function is x squared minus 2. Our derivative is 2x. And using the algorithm for Newton's method, x1 is going to be 3/2. So once I keep track of that, I can sort of clean this up a little bit and give myself some more room to go ahead and figure out x2. All right, so x2 is going to be x1, just following the algorithm. It's going to be x1 minus f of x1 over f prime of x1. Now I've got a concrete value for x1. It's 3/2. I know what f is. I know what f prime is. And so I can just go ahead and calculate this. This is going to be x1, which is 3/2, minus f of 3/2 divided by f prime of 3/2. And I know what f does to anything I input. It squares it and subtracts 2, so I've got 3/2 minus, careful with my minus signs in my parentheses here again, f of 3/2 is going to be 3/2 squared minus 2. That's my numerator, and my denominator is going to be 2 times 3/2, since f prime just doubles whatever you put into it. Now, let me get rid of my statement of Newton's method. Since, remember, we're going to stop at x2, so we don't actually need the algorithm in front of us anymore. We just have to finish up, get a concrete value here, some nice tidy fraction, and that'll be where we stop, right? That'll be the end. And I know it's the end because I said that's where we're going to stop, right? We're just going to find x2 and be done with it. So I just need to clean this up. This is going to be, following this calculation up here, this is 3/2 minus 3/2 squared is 9/4 minus 2. That's my numerator, and that's divided by a nice simple number, 3. Right, so 9/4 minus 2, just need to get a common denominator, so this is really 8/4, and so this is 3/2 minus 9 minus 8 over 4 over 3. Right, so this is, up here, this is really 1/4 divided by 3 is going to give me 1/12. And so I've got 3/2 minus 1/12. Right, now just to finish this off and get one nice tidy answer, I just need a common denominator again. So this is missing a 6 over 6 to make the denominator 12, so this is 18 minus 1 over 12. In other words, 17/12. Assuming, of course, that I made no arithmetic or algebraic mistakes in there. This is what we end up with, the value of 17/12. Now, what I want you to do is actually figure out how close we were at every stage. All right, so use a calculator or Wolfram Alpha or Desmos or whatever you want to use. Go ahead and plug in the actual square root of 2. Right, so that's going to be like 1.414-ish. And see how close x1 was. Right, x1 was 1.5, so we're off by a little bit. And see how close 17 over 12 is. Just to give you a sense that if all is going well, you are actually getting closer to your root. Now, I want you to do that, of course, but I also want you to think about what could have possibly gone wrong here. All right, so as I mentioned at the very beginning, we rephrased the problem as finding a root of a function which was x squared minus 2, but we had to be very specific and say that it was the positive root, because x squared minus 2 has both a positive and a negative root, plus and minus the square root of 2. So, what could have possibly gone wrong with this? Well, we've got our function x squared minus 2. It looks something like this. And we've got our positive square root of 2 here. This is what we were trying to estimate. We've got our negative square root of 2 here. And just try to think about how important this initial guess can actually be, right? How important the location of x naught can be, right? We made our initial guess x naught to be right about here, right? We guessed x naught was 1. Or rather, we defined x naught to be 1. Our initial guess was 1. And I mean, you can make this initial guess. I told you that's what we were going to use, but in theory, you would be making this guess by yourself. And the way you want to make this guess is just by, like we do in class all the time, think about roughly how large the square root of 2 is, right? It's somewhere between 1 and 2, since 2 is somewhere between 1 and 4. Therefore, the square root would be between 1 and 2. And so 1 is a decent guess, 2 would be a decent guess, 1.5 would be a decent guess, right? Things like that. So how do we know if we had somehow made an error here? Well, first of all, think about what could go wrong if we had taken our initial guess to be x naught equals 0. Right? Think about how that could possibly lead to some complications, pretty quickly in fact. And think about what would have happened if we had instead started off with x naught equals -1 instead of 1. Right? What could have happened with this that would have run us, sort of down the wrong path, right? That would have gotten us into trouble. So think about both of those points, right? What could happen if your initial guess, in this case, were 0? What's the badness that happens there? And what's the badness that happens if you start off with x naught equal to -1? To figure out what happens when x naught is -1, go ahead and repeat this exact same process. All right, that's an exercise for you. Repeat this Newton's method approximation for x naught equal to -1 instead of +1. Find x2, and then tell yourself or think to yourself what's actually happening here, right? Am I getting closer to the positive square root of 2, or is something else happening? All right. So we do have to be careful with Newton's method. These are all things that you should be thinking about. Anytime we do anything in this class, you always want to think about how to break it, right? What could possibly go wrong with this, and what steps do I need to take to be careful to ensure that I actually get the result that I want. In this case, we wanted an estimate for the positive square root of 2. We made a reasonable guess of 1, since we know that the square root of 2 is, we know from experience it's about 1.4, but in general we know it's somewhere between 1 and 2. All right, so think to yourself what could happen if you make an initial guess that's in exactly the wrong place, like this one, or that's just a little too far away. What can happen in both those cases?